Welcome to Physics Error Thursday. Today I've got a really key error that is made by a lot of students, and a lot of students are making errors and losing marks when they actually understand the physics. But in physics we do not give away marks cheaply. We do not give away marks for just showing some understanding if you are not accurate enough in the way that you use the precise terms that have really definite meanings in physics. So watch out for this one, please. If you're asked to define something, if you're asked to give a definition of something, then one of the best ways to think about it is to use an equation to define that. But if you haven't got that, you need to be giving the specific definition. And the reason for that is that actually in physics, if we get a definition of something wrong and we use that to make a further conclusion, then that can have some really important and really damaging consequences to us in our physics. So I'm going to show you a couple of typical ones. This is the classic example of this, if you like. This is, you're asked to describe how heat changes the density of something, because maybe, I don't know, you're doing convection currents or something like that. And you say, the particles expand, and so the gas gets less dense and, hang on a minute, the particles do not expand. If you say the particles expand, you probably mean those particles there get further away from each other. You probably mean that particle picture expands. Those particles have expanded to become further apart, those particles. But you haven't said that. You have said, the particles expand, and that is what we're going to mark that as. You need to be that clear on the meaning. So if you say, the gas expands, then the consequence of that is the particles are getting further apart. Okay, that's one. And here's one that's being made recently by some A-level students. The vibrations are side to side. They were trying to define what a longitudinal wave is. The vibrations are side to side. Well, hang on a minute, because the vibrations of this wave is side to side as well. But you can see that is not a longitudinal wave. So what are we going to upgrade that to? We're going to have to say the vibrations are parallel to the direction of wave energy transfer. That's key. Okay, a longitudinal wave, the oscillation is parallel to the direction of wave propagation. You need to be that specific. Learn the definitions of these things. They are pretty simple marks to get, okay, but they're easy marks to lose because you think, I know this, got it, and you move on. You've got to be that specific in your definitions of things in physics. So this one is longitudinal, and these lines are not wavefronts, so this is not a wavelength between here and here. It's a wavelength between compression and compression. These lines are positions of the particles. They represent the positions of the particles in this wave. This one, however, even though the vibrations are side to side, is actually a transverse wave, and it's a transverse wave because the energy is moving downwards and the vibrations, the oscillations, are at right angles to that. So to define a transverse wave, you would say the vibrations are perpendicular to the direction of energy transfer. And this is the correct definition of a longitudinal wave. If you're asked to draw a diagram of this, well, you're going to need to include these labels. The key is direction of the energy, direction of the vibration, in distinguishing between your longitudinal and your transverse waves. So all those mistakes, and well, what do you do with them? That's the key bit, okay? Do not be worrying about making these errors. What do you do with them to make sure you don't make the same ones again? Well, here I've got some really excellent example of that. Hopefully your teacher's got time at the end to be working through some past papers. If not, get yourself online, find your exam board and download them. What you do with those errors is key. This young man's not been happy with just making the errors. Well, he's had a go through this once. You can see the black pen. And then he's gone to the mark scheme and he's marked it himself, and he's made sure he knows how to improve it. And by looking at those mark schemes, he's given himself some praise as well, but he's even saying, even when he gets it right, how can I improve this? That's really key. The more that you do that, the more you get used to the demands of the syllabus, the demands of the people who are marking your work. The words they use are key. If there's ever anything that like underlines, it means they're insisting on seeing that particular word. If there's anything emboldened, like an and, it means you've got to do that and something. Always be thinking, how can you make it even better? Even if you think you understand this, well, you might have understood it, but don't actually have anything in the mark scheme. See you next time on Physics Error Thursday. Don't worry about making the errors, just learn from them. Thank you for watching Gorilla Physics. Please do like, share and subscribe. That really helps me be more useful to more people. Also, please go ahead and check out Gorilla Chemistry and Gorilla Biology. You can expect the same sorts of things, past paper questions and videos to help you understand topics. Thanks once again for watching.